Okay, this time let us try using an analytical method to solve for the sum of these three vectors a, b, and c. We are trying to solve for the resultant r, which is equal to a plus b plus c. Okay, so we will now use component method. So this method is quite lengthy. Medyo mahaba yung process na gagawin natin. So I've list down all the steps that we need to do to solve for the sum of a plus b plus c. The first step is to solve for their scalar components for our vectors. So scalar component ng a, scalar component ng b, and ng c. Next step is to solve for the components of r, galing doon sa mga na-solve natin na scalar components. And then, with the components of r, we can solve for the magnitude of our resultant r. And then, we can solve for the direction of our resultant r. And then finally, since meron na tayong magnitude and direction, we can write our resultant vector r. Okay? So this is our given. Same given as before, a, b, and c. So let's try using component method to solve for their sum. First step, we will need to solve for the scalar components of each of this vector. So lagyan natin sa ilalim. And let's solve for their scalar components. Now, in order to solve for the scalar components, we will use this equation here. Given a vector v, the scalar components of vector b is given by this equation. So we have two components for this particular example. So the first is the adjacent component that could take a value of plus or minus v cosine theta. Second equation that we will use, v opposite, so the opposite component of vector v is equal to plus or minus v sine theta. So ito yung equation na gagamitin natin. If you look at the equations, so we have the magnitude v, magnitude ng ating vector v here, times either cosine or sine of the angle that we have. Okay? Now, para mas madali siyang ma-memorize, we just need to remember that adjacent corresponds to cosine. Okay? So if the component is adjacent, we will use cosine. So if it's opposite, we will use sine. Okay? So yun yung gagawin natin. So I'll show you how to use these equations in solving for the scalar components. So let's start with this first vector here, vector A. Okay? For vector A, first step is to do a sketch ng ating vector. Hindi na natin kailangan ng ruler or protractor. We don't need an accurate representation of the vector. Just a simple sketch will do. Okay? So let's draw an axis first. Okay? So our vector is in the direction 55 north of east. So that means galing tayong east, papunta tayong north by 55 degrees. So for our direction, let's draw a direction northeast. Okay? So we will start from east dito, papuntang north by 55 degrees. So this could be our angle. Okay? So our vector A will look like this. So again, sketch lang ito. Hindi ito siya accurate na representation. Pero a sketch is all we need. Okay, so this is 55 degrees. So this is our angle theta, 55 degrees in this case. Now, the scalar components of vector A, we have two. This is our x-axis and this is our y-axis. So, the first scalar component niya is what we call the x component. Okay, so the x component is the x value at this point here. Itong point na ito. Kung anong x value dyan, that is our a sub x, or the x component of A. But the next component we have is the y component, which is the y value of this point here, a sub y. Okay? So how do we solve for a sub x and a sub y? So recall, this is the equations that we will use. And again, para ma-memorize natin siya, kailangan natin tandaan, adjacent corresponds to cosine. Okay? So we have two components here, a sub x and a sub y. Now, the adjacent component is the component that is connected or adjacent, makadikit, dun sa ating angle. Okay, so for between these two, a sub y and a sub x, nakadikit yung ating angle sa a sub x. Okay, so ibig sabihin, a sub x yung ating adjacent na component. So let's write the equation for a sub x. So a sub x is equal to a, magnitude a. And then since this is adjacent, nakadikit yung x sa ating angle, we will use cosine theta. Okay? Now, next, we need to determine if a sub x is positive or negative. Now, from our diagram, since ang ating a sub x is located dito sa positive x, andito siya, positive x-axis, then our a sub x will take a value of positive. Okay? So, yan yung ating equation. Now, let's solve for the x component of vector A by substituting yung values that we have. So, A, 5 newtons. Cosine, the angle is 55 degrees. Okay, so using our calculator, let us solve for a sub x. 5 degrees. So we have, let's take 3 significant figures. So we have 2.87. A sub x, 2.87. Just take yung unit ng ating magnitude, that is Newton. So this is now the x component ng ating vector A. Now let's solve for the y component of vector A. So a sub y is equal to magnitude. Now, let's look at if this is adjacent or opposite. So again, nandito yung ating a sub y, and clearly it is not connected to our angle, so we will use the equation for opposite. Okay, so kanina adjacent is cosine, so since opposite, we will use sine. Now, we need to determine if this is positive or negative. So let's look at our diagram. So clearly, ang ating a sub y is nasa positive y-axis. So this will take a positive value. Okay? So solving by substituting our values here. Okay, so plugging this into our calculator. So we have 4.9 per round up, so that is 4.10. So a sub y is 4.10. So we'll take yung unit ng ating magnitude. So that is for a sub y. Okay, so the components of our vector A, we have a sub x and a sub y. I will do the same process for vector B and vector C. So let's do that now. So this is our vector B. So let's try to draw a sketch of vector B. Okay, so yung angle is 23 degrees west of south. So we will start from south, papunta tayong west by 23 degrees. So this is south, punta tayo sa west. So this should be 23 degrees. So our vector B will look like this vector here. Okay? So our components for vector B, this is B sub x. This point here, that is our B sub x. And this point here, this is our B sub y. Okay? So let's write the equation for B sub x. So B sub x is equal to, let's write yung magnitude B. Tapos, let's determine if this is adjacent or opposite. So since andito yung angle natin, tapos andito yung ating B sub x, so clearly this is opposite. So we will use sine theta. Okay? Next, let's determine if it is positive or negative. So from our diagram, ang ating B sub x is located sa negative x-axis. So this will take the negative sign. Okay, substituting our values. So this is negative. Okay, so using our calculator, we have negative. So we got a value of negative 1.17. Taking the unit of our magnitude. So this is our B sub x. Okay, next, let's write the equation for B sub y. So B sub y is equal to magnitude B. And let's determine if it is adjacent or opposite. So this is our angle. This is our B sub y. So clearly it is adjacent to our angle. So we will use cosine. Next, determine if it is positive or negative. So since from our diagram, our B sub y is in the negative y-axis, so this will take a negative value. Okay, so let's substitute. Okay, so using our calculator, So we got a value of negative 2.76. So negative 2.76 will take the unit of our magnitude, Newton. So this is the y component of vector B. Okay, so let's do the same for vector C. Let's sketch first yung ating vector. Okay, so the direction is northwest. So that is between north and west. So yung ating vector will look like this. Okay, and both angles, here and here, are 45 degrees. Now we only need one angle, so you choose one. I will choose this angle below. That is 45 degrees. So this is our vector C. Okay, so the x component is this point here. And anong value ng point na yan? That is C sub x. And the y component is this point here. This is C sub y. Okay, so let's write our equation for C sub x first. C sub x is equal to, let's write yung magnitude, and then determine if it is opposite or adjacent. So this is our component C sub x. Tapos, ito yung ating angle, so they are adjacent. Nakadikit yung angle sa component natin. So we will use cosine theta. Now, determine if it is positive or negative. So from our diagram, andito siya sa negative x-axis. So this should take a negative value. Okay, so let's solve for this. So using our calculator, okay, so we got a value of negative 2.82. So negative 2.82. Round off 83, 2.83. And we'll take yung unit ng ating magnitude, Newton. So that is C sub x. So this is our x component for vector C. Now solving for the y component, C sub y. Let's write the equation. So let's start with the magnitude C. So let's look at our component, C sub y. Tapos andito yung angle. So clearly that is opposite. So we will use sine theta. Now let's determine if it is positive or negative. So ang ating C sub y is on the positive y. So this is actually positive. Substituting the values. So let's plug that in to our calculator. So we got the same thing, 2.83 rounded up. This time this is positive. This is the y component of vector C. So finally, we were able to solve the x components and the y components of these three vectors. Now this time, using these components, a sub x, a sub y, b sub x, b sub y, c sub x, and c sub y, let us solve for the components of our resultant vector r. So if you have a vector sum expressed by this equation r, if you have r is equal to a plus b plus c, if this is true, then these next equations are also true. Okay? Kung ganito yung form ng ating vector sum or any vector equation, then these two equations here, r sub x and r sub y, is also true. Diba? It takes the same form, pero the difference is these are all x components and this below are all y components. Okay, so these are all true. So we will use these two equations here to solve for the x component of our resultant, r sub x, and the y component of our resultant, r sub y. Okay, so let's start first with the x component. Okay, so r sub x is simply a sub x plus b sub x plus c sub x. So we've solved that already. So we'll just plug that in sa ating equation. Okay, so using our calculator, we can now solve for the x component of our resultant, r sub x. So we got negative 1.13. The unit is in newtons kasi lahat nung inad natin is in newtons. So that is r sub x. Now, solving for r sub y, we have this equation here. We've already solved that from our previous step. So, substitute na lang natin yung values. Okay, now using our calculator, this is now 4.17 newtons. That is our r sub y. Okay, so now we've solved for the x component and the y component of our vector r. Okay, now that we have our x component and y component for our resultant vector, we can now proceed to the next step, which is to find the magnitude of r. Okay, now to solve for the magnitude of our resultant vector, we will use the equation r is equal to square root of r sub x squared plus r sub y squared. Okay, so makita natin dito na using our x component and y component of the resultant, we can solve for the magnitude of our resultant vector. So let's do that. Let's substitute the values inside this radical here. Okay, so solving this in our calculator. So we got 4.32. So the magnitude of our resultant vector is 4.32. Unit is newtons. So this is now the magnitude of our vector. Okay, so we got that galing doon sa components ng ating vector r, resultant vector r. Okay, next, let's solve for the direction. Let's solve for the direction of vector r. Okay, so to solve the direction for vector r, we need to solve first the angle phi, which is given by this equation. Inverse tangent or arctan of the absolute value of r sub y over r sub x. Now, itong angle na ito, phi, this is the angle from the x-axis. Okay, so galing sa x-axis itong angle na ito, angle phi. Okay, so let's substitute our given values to solve for phi. So phi is equal to inverse tangent of r sub y over r sub x. So using our calculator, so we got the angle 74.8 degrees. So ngayon, meron na tayong angle phi. Now, we need to solve for the direction of our resultant vector r. So, since this is the angle from the x-axis, we actually have 4 possible angles from the x-axis. This angle phi here could be this angle here. Pwedeng ito, kasi this is from the x-axis. But it could also be this angle here. That is still from the x-axis, or it could be this angle here, which is also from the x-axis, or finally, it could be from this angle here. Now, we need to know alin dito yung angle na na-solve natin, phi, for our specific resultant vector. Okay? Now, in order to answer that, we need to understand the concept of quadrants sa ating x and y axis. So, this box here actually belongs to quadrant 1. Any point that you put in this quadrant, it will always have an x value that is positive, and it will have a y value that is positive. So, positive yung x and positive yung y dito sa quadrant 1. Now, for this second quadrant here, quadrant 2, ang x natin is negative. No? If you have a point here, the x component of that point is negative, so negative yung x, pero the y is still positive. For quadrant 3, we have still negative x, and the y, if you have a point here, y is also negative. Negative yung y. Now, quadrant 4, so you have any point sa quadrant 4, you have x that is positive and y that is negative. So, ito yung possible choices natin. Now, in order to know kung saan dyan sa apat na yan nakalagay itong ating angle phi, we need to look at the x component and y component of our r. Now, from this substitution here, we know that our x component is negative and our y component is positive. So that belongs to x component negative, y component is positive. It belongs to quadrant 2. So from our components, we determined na nasa quadrant 2 dapat yung angle natin. So the direction of our resultant vector r is towards this direction here. Parang ganito yung ating direction. And this angle phi, that is 74.8 degrees. Okay? So kung use natin yung ating four directions, north, east, south, and west, this is from west papuntang north. So the direction is actually 74.8 degrees north of west. So galing west papuntang north. So ito yung direction ng ating resultant vector. Okay? So now that we have the magnitude and we also have the direction, we can now write our resultant vector r. So simply, our resultant vector r is, magnitude is 4.32 newtons, and the direction is 74.8 degrees north of west. So finally, using the component method, we are able to solve the resultant vector, or the sum of our three vectors, a plus b plus c.